Good evening, everyone. I'm Sophia. My project is QABot, a chatbot for open question answering using neural networks. During the second phase of my project, I carried out the exploratory data analysis and created neural networks and generated some initial results. Although the MS Marco dataset contains 100K records, but the data is in a form of unbounded set of domains. So therefore, the size of the vocabulary for each domain is small, and it results in the results are not as good as human-like. My model suffers from the diversity of the context available in the MS Marco dataset. Due to this challenge, I decided to search a supplementary dataset that will help me to demonstrate the feasibility of my goal, that is to use neural network to create QA system and with possibly human-like responses. The supplementary dataset that I have chosen includes Twitter-based customer service data, and I even made it more domain specific by filtering this data to use only the Apple's customer support queries. As you can see, this is the outcome of my MS Markov model with the same neural network, which is not so meaningful outcome. And this is the one with the same model I implemented with the data of Twitter customer support data, and it's showing more meaningful and more relevant results. So now in the EDA, I have created a question type distribution and a distribution of question category. So as you can see, in the distribution of WH word, where it shows that who, what, where type of questions available in the MS Markup dataset, and it does not tell my model whether the who query is about a sportsman, an actor, or a politician, where the question where it asks about a description of an entity, or whether it's asking for a location, and the location can vary from hospital to restaurant. And when the question is asking about an entity, it might be a scientific concept, it might be a literature concept. So there is a diverse of concept, and which eventually giving less number of vocabulary for each domain, and it's difficult for my model to learn. And in the workload visualization from the left, as you can see, the Apple customers questions data, it clearly shows that it has more domain specific information, like it has words for Apple's and Apple's product, and the words are related to computer, mobile, internet related concepts. So it has a specific domain which my model can learn from. And on the right hand side, in the MS Marco dataset, it has more generic domain, like it talks about country, weather, symptoms, and symptoms of medical diagnosis, pain, medical concepts, etc. So this kind of diverse concepts makes it difficult for the neural network to learn the concept on its own, and it's that is why with the same neural network, the one dataset is giving me good results, but the other one without a domain specific and less of vocabulary didn't give me human like responses. So now this is the visualization of answers for the two datasets. The next idea that I have done is the length of questions. As you can see, for the customer service dataset, it has fairly long questions, and whereas the MS Marco dataset is consistently very short. I see, the same issue is also exist for the answer length, and this is another reason why the model do not have a fair amount of words in the vocabulary to learn, and thus performs poorly when generating or predicting the natural language sentences. Next, this is the distribution of number of words in a question and answer for the two dataset that I have chosen. This is the neural network that I have designed. It shows the component and the flows within the neural network. So now my neural network, the heart of my neural network is sec to sec algorithm, a denising autoencoder over sequences. The goal of this sequence to sequence model is to take a variable length question sequence as input and generate a variable length answer sequence as output. So among the words of the question and the answer, there is no one-to-one relationship, and there is no one-to-one mapping. They might not be same, and also the question and the answer length can vary. So this is that is why we are calling it a denoising autoencoder, as if the question is a noisy version of my answer. So and in my project, I also created question answer pairs and a vocabulary for them, the words, where this vocabulary is a dictionary which maps each word to a unique ID. I also the sequence are of varying length. So in order to make the sequences of same length, I used a pad token to the sequence length of the longest sequence. To indicating the beginning and the end of the sequence, I used starting of sentence and end of sentence tokens. And the batch of data that I am feeding to my neural network, uh, it it is in the form of a nested tuple, because the training of the sequence to sequence model require both the pair of question and answer. So my neural network contains three components. One is embedding layer, encoding layer RNN, and decoding layer RNN. The purpose of the embedding layer is to convert the token into feature vectors. And the encoding layer takes the embedded questions, and it uses gated recurring unit. And as we are dealing with sequences, we need RNN. And encoder layer RNN encodes the variable length question sequence to a fixed length context vector, and this context vector contains the semantic information about the question. Then we have a decoding layer RNN. The goal of this decoding layer RNN is to take an input, uh, uh, a word, and a context vector, and predict the next word in the sequence. So it consists of three components. The first one is the GRU cells layer, which is doing the decoding operation in a step by step, one step at a time in a token by token fashion. And the second component is an attention mechanism layer, which is the attention mechanism is the key of my sec to sec network to perform well. And the goal of the attention mechanism layer is to pay attention what is important stuff and selectively ignore the unimportant, superfluous, and distracting inputs. The third component is a fully connected network which predict the next token from the concatenated output of attention context, and which is coming from my attention layer, and locally decoded context coming from the GRU layers. So attention mechanism helps to learn the decoder how to ignore the noise present in the data. So in order to find out the importance of each token, I use the attention width, which is computed by dot score. The training in RNN can be done using two approaches. One is autoregressive, another one is teacher forcing. In autoregressive approaches, it use the predicted token of a time step t by taking the token, the most likely token by sampling based on probability, and pass it to the next time step t plus 1. So this approach is a slower process, but it is really good for generalization. So I use this one as a in my prediction, because this does not require to know the answer. It can sample the predicted token of the previous step and use as an input to the next step. The next one is next approach is teacher forcing approach. In this approach, it gives the model the correct token at a particular time step, and it allows it to continue its prediction for the next token. And this approach makes it easier to predict the subsequent token correctly, because if the model knows the correct token at a particular time step, it can correctly predict the next one. So it's an ensemble of both the method. I have used the combination of both teacher forcing and autoregressive is used in while I'm training the model, and I'm randomly deciding which one the model should be trained on. And then for prediction, I have used autoregressive because it does not require to know the answer. This is the training loss plot. So in this two plot, we can clearly see that it is easier for TWCS dataset to learn, and losses are decreasing faster for TWCS. As the losses are decreasing, where our model is learning properly. So this is my presentation, folks. Thank you.